All right, so now we're in chapter 15. Chapter 15 deals with the respiratory system. So looking at our respiratory system, let's look at the entire process of respiration. Respiration is the entire process of gas exchange between the atmosphere and body cells. And so there are a few things going on here. One is breathing, also known as ventilation. That is the movement of air into and out of the lungs. Next is external respiration, and this is gas exchange between the blood and air in the lungs. So oxygen is going to fuse from the air in the lungs into the blood. Carbon dioxide diffuses in the other direction. Next is transport of those respiratory gases, and this is by the circulatory system. All right. And then when we get blood by our body cells, we're going to have internal respiration. So this is gas exchange between blood and the body cells. And so oxygen diffuses from the blood into the body cells. Carbon dioxide diffuses in the opposite direction. And once we're in the cell, then we're going to have cellular respiration. And this is a process of oxygen utilization and carbon dioxide production at the cellular level. All right. So here we're going to use oxygen to break down glucose so the cells can have energy. So that's what we do in aerobic respiration. We're going to take glucose using oxygen. We're going to break down that glucose. That's going to produce cellular energy, or ATP. And then the byproduct of that is carbon dioxide. And so this is why we always see these diffusion processes working this way. Because cells, as long as they're alive, are going to have a constant demand for energy. If they have a constant demand for energy, they're going to constantly need to use oxygen to break down glucose for it. So we're constantly consuming oxygen, and we're constantly producing carbon dioxide from breaking that glucose down. All right, let's take a look at the organs of the respiratory tract. So looking at the upper respiratory tract, and then we'll look at the lower respiratory tract. So starting with the upper respiratory tract, first is the nose. So the nose is the external organ of respiration. There are two openings called nares. We commonly call them nostrils. All right. Those nares can have internal hairs in them, and this is going to prevent the entry of foreign particles. Behind that is the nasal cavity. So all this is the nasal cavity. So this is a hollow space behind the nose. It is divided by a nasal septum, which you can't see on this picture, but you can see on me right there. That's the nasal septum. All right. So this divides the nasal cavity into left and right portions. And also we have nasal concha. So these bones that curl into the nasal cavity are the nasal concha. So what the septum and the concha do is they add surface area. All right. And so all these areas are lined by mucous membranes. So by having more surface area, we have more mucous membranes. And those mucous membranes are going to do several things for us. One is they're going to clean and filter the air, so all the dust, dirt, pollen, whatever that's dissolved in the air, that mucus is going to help trap. They're also going to moisturize that air and also warm that air. Now, cilia in these membranes, so it's pseudostratified ciliated columnar epithelial cells there, are going to move, so that cilia is going to move that mucus down here to our pharynx or our throat, and then we're just going to swallow that mucus. So this happens throughout the day. So, ciliary action is going to move that mucus down to our pharynx, and then, I just swallowed some more mucus. And we do that throughout the day. All right? Next are the paranasal sinuses, and you can only see a couple of those. So those paranasal sinuses are air-filled cavities in the cranial bones. They will connect and they drain into the nasal cavity. They are also lined by pseudostratified ciliated columnar epithelial cells, right? So those mucus cells are going to have the same, so those mucous membranes are going to have the same functions as I mentioned with the nasal cavity. Another function that these sinuses have is that they reduce the weight of the skull, and they also give voice some resonance, all right? So next is the pharynx. All this is the pharynx. So this is a passageway between the nasal cavity and the larynx, which is our voice box, which is right there. All right. So this is going to help produce some of the sounds for speech. All right. So let's move to the lower respiratory tract, which starts here with our larynx, which is our voice box. It houses our vocal cords. That's why we call it our voice box. Right at the top of that, we can see this thing right there, and that is known as the epiglottis. All right? So this is a flap-like structure near the entrance of the larynx. and it's going to cover over the opening larynx while swallowing. Really what happens when we swallow is our voice box moves up, that epiglottis moves over, and we direct swallowed substances to our esophagus. All right? Now, if we look at a top-down view, so this is showing our larynx with, all the tissues away except for the cartilage and the bone. So top-down view of our larynx, there's a drawing here, and then this is a picture of the actual larynx there. We have this opening here between the vocal cords, and that is known as a glottis. So it's a triangular slit between the vocal cords. This is closed whenever we're going to swallow anything. To produce voice, to produce sounds and vocalizations, what we do here is we are going to actually close those vocal cords, and we're going to push air against those vocal cords. And when we push air against the vocal cords, they're going to vibrate, and that produces the sound. And then we're going to manipulate that sound, with our mouth, our teeth, our lips, our cheeks, our tongue, our pharynx, and that's going to produce vocalizations. All right? So, a couple of things that influence sound. One is your pitch. Your pitch is how high or low your voice is, right? And this is due to the lengths of the vocal cords. So if you look inside of a piano or see a harp, the higher notes are the ones that are the chords that are shorter. The longer note, the deeper notes are the ones that are longer, right? And that's the way our vocal cords are as well. The deeper your pitch is, the longer your vocal cords are. All right? Now you can adjust this by adjusting tension. If you put more tension on your vocal cords, you can make your voice go up. It's going to have a higher pitch like this. All right? Or, if you put less tension on, then your voice will go down like this. All right? So next is intensity. That's also known as loudness. And this is due to the amount of air we force over the lungs. So that's going to make our voice loud. All right. So moving on to the next thing. After the larynx, this is the trachea. So trachea is also known as our windpipe. So this is between the larynx and the bronchi. So the larynx here, bronchi are smaller tubes past it. The trachea is also lined with cilia, so pseudostratified cilia, columnar epithelial cells there. And they're going to produce mucus. And then ciliary action is going to move that mucus up to our pharynx. And then, I just swallowed some more mucus. I think I might have mentioned earlier this semester, but smoking inhibits ciliary action and actually stops you from making some cilia. All right? And so what happens with smokers is that smokers will develop that cough, that hack, and that's really the only way they can move that mucus up out of their trachea and their bronchi. Now, their trachea has these rings to it. Those are hyaline cartilage rings, and this keeps our trachea open all the time. Now, choking is tracheal blockage, so you have something lodged in there and you can't get air into or out of that. All right? Next is a bronchial tree, so you can see we go from a large tube to smaller tubes. That's a bronchial tree. So this is the bronchi and all their branchings. And these are going to carry air from the trachea to these small little air sacs known as alveoli. So here are the alveoli. So these are the small air sacs of the lungs. That's where external respiration occurs, so we can see the blood capillaries over those. Lastly here in organs is the lungs themselves. So these are the organs of respiration, and they are composed of alveoli and all these bronchi and bronchioles. They are soft and spongy and cone-shaped. The right lung is larger than the left, and that's because the heart would be in that area right there.